Well, everyone, I'm going to show you how the simulation system works, which is an important feature that was mentioned for this project. So I'm going to demonstrate using the virtual GTD how we would handle the simulation system for you. So here I have this little lightning bolt, and when I click on it, I have several simulations here. I'll give you an example. I'll show you, for instance, how the substation is right now. For example, you can see that both of my electrical transformers are fully connected, both on the high voltage and low voltage sides, right here and right over here. So what am I going to do? I'm going to apply simulation 6. We can give this simulation a name, okay? At first it was supposed to be a challenge, right? You would start the simulation without saying what it is, and the person has to figure it out. This is customizable. So I'm going to click here. Here I'm saying that it's going to be a shutdown with transformer blocking protection. So it's going to show here, starting the simulation, and I open the circuit breaker here for transformer 2. Then the power flow is completely recalculated. The current now flows entirely through transformer 1. But what I want to show is the following. In the simulation, we have an automation here in the substation, which works as follows. When there is a loss of power in both transformers, when both tertiary windings here are without voltage, my auxiliary service is supplied either from the tertiary of transformer 1 or transformer 2. If I lose both of these sources, then I need to activate the emergency diesel generator. And then the emergency diesel generator is monitoring the voltage on the bus bar. So now I'm going to run simulation 7. What does simulation 7 do? It opened the circuit breaker 0 amperes. I have no voltage here at 13.8. My 380 bus bar is at 0, so that noise means the diesel has started up. Look at the smoke over there. So if I go over there, the diesel is running, it's operating. And now to power this bus bar, I need to close the bus bar circuit breaker. Once that's done, I supply my 318 auxiliary service. And then I can restore my request. I have my the 86 lockout is. And now I have all my supervision indicating that I've reset the 86. And so guys, I need to resolve this here in the field. I have to reset the 86 relay. I'm going to reset it. I'm going to close my circuit breaker. Right now, I am going to open up my GDG. And now I am finally able to safely shut down the GDG. I'm going to come here. I can switch the control to manual, switch it to local. I'm going to shut down my GDG and let me check how my supervisory system is doing. Let's see if I performed the maneuver correctly. You also need to energize the low side of the transformer. You have to reset the 86. The control is locked. It is most likely because I currently do not have any auxiliary service power to be able to properly operate this equipment at this time. Circuit breaker. What am I going to have to do? Start the diesel again, put it on the bus bar. So as you can see, all of this right here, folks, is essentially maneuvering. I am going to go ahead and start it up locally on this machine. I'm going to head back over here and get my diesel engine started up once again. Close the circuit breaker. Actually, I'll close it from here. I've powered my bus bar. My bus bar is powered. Now I'm going to try. The automaton is still locked. It's released. The automation is released. I close my circuit breaker. At this moment, it has fallen significantly to 380 units. The automation system has already successfully toggled both of the circuit breakers. Now I'm going to shut down my diesel. And now I have current here in my auxiliary service. I've normalized the substation. So all of this, folks, was based on a simulation. And you can see that the whole system is recalculated. So I'm going to give another example. Here I have all my load coming through this transformer. I'm going to unlock my 86 and close this circuit breaker. And the load is recalculated. It drew 13 amperes. That must be because of the auxiliary service configuration. This one, transformer 2, was left with the essential loads, and transformer 1 was left with the non-essential loads. So that's why the load is low. The load on the transformer. And then there's tap switching. All of that changes things. I'll give another example here. Bus reactor. If I open the bus reactor circuit breaker, I'm going to raise the voltage. So the voltage goes up. If I close the capacitor bank, the voltage will go up even more. It went up to 200. All of this is calculated, folks. So I can do, for example, a simulation where I open capacitor bank, if I'm not mistaken, is the first one. We are looking at the shutdowns of the capacitor bank. So I will start the simulation. And as you can see here, the capacitor bank has now been opened. And then I have to go back and reconnect the capacitor bank anyway. That's how the simulation system works. Guys, I start the simulation and it opens. It does what it needs to do, and then we have to interact with the system and redo it. I executed all the commands through the supervisory system, but we can also perform the commands locally by opening and closing the circuit breaker. So I'm going to simply give a local command right here, just as an example. So what I would like to show you right here in front of me is this particular item that I have been preparing to share with all of you today, as we take a closer look at everything it has to offer in this session. The circuit breaker, this circuit breaker refers to this specific electrical line shown here. In the diagram, it is clearly labeled as circuit number 2 on the schematic. This circuit breaker is identified as number 523. So I will first open the panel, then switch it over to local control, and finally open it. The indicator strip is green. If I check on my supervisory system, the circuit breaker is open, and now I can operate, for example, a disconnect switch. I'm going to operate this switch here. I'm going to close it. 8914, it's this one here. I'm going to close it. First, I carefully set my local remote toggle switch to the local position, and then I proceed to firmly press the close button. I'm going to look up here. It's closing. I'm going to open it. It's opening. And folks, it can also happen that an incorrect operation is performed. So I'm going to close the circuit breaker. Okay, now it's turned red. I'm going to open a disconnect switch under load. Let me locate a disconnect switch. And I'm going to open this disconnect switch here under load. So I'm going to go ahead and open it up. The code for this panel is 8912-8912. Please locate component number 8912. It is this specific one right here, located just upstream of the main circuit breaker. If I were to open it while it is under load, then something significant should happen. So that's the effect when opening under load and the game notifies you. Oops. Operation error. Disconnect switches cannot be opened under load. I click on reset and it returns to normal. Then I can restart my operations. So everyone, this is the simulation system. Now I'm going to show a bit about the primary substation, some operations in a primary substation. All right, everyone, this is our primary substation scenario. Here I have a primary substation of 38, 380, and here a factory. I'm going to show, for example, a bit of the factory. So there's a factory here with motors. The motors here are running, the shaft is spinning, you can see it here. I also have an elevator here. If I come over here, I can see it moving. And I also have some teaching panels. So for example, I have a panel here that I can hover the mouse over. And it will tell me what the equipment is about. So here I have an electric motor, and if I press the letter I pull up its information. It brings up a PowerPoint presentation. Everything related to this equipment. This is a video. So because of that, I can show you videos, I can show you various photos, or even PDFs. It is really all about that specific equipment. Now right here, folks, I have a full panel of circuit breakers for you to see, so take a close look. The power factor is exactly 0.9. So on this panel, for example, I show power factor, active power, reactive power, and then what happens. For instance, if I were to go ahead and shut down some of this equipment, just take a look. I am now in the process of turning off these motors. The power factor is recalculated. The voltage and current here on the meter are changed. So I'm going to turn off more things. So look, the power factor became 1. This here, folks, I'm operating capacitor banks. I'm going to turn everything off. My power factor dropped to 0.73. And I have an increase in current. If I try to balance my power factor, my current drops. Anyway, folks, this is a matter of power flow. Now I'm going to shut down the factory from my primary substation. So I'm going to go. I've opened up my substation and I've found something quite interesting. If I press the M key and then click right here, I have these energized conductors. Now I know for sure it's energized. It's turned red, so it's definitely energized. So what am I going to do, folks? I'm simply going to open the circuit breaker. Go ahead and open the circuit breaker. You can see it has turned green here. Green here. If I come here to my panel here in the factory, all of my voltage levels have suddenly dropped down to 0, and the electrical current has also hit 0. There is absolutely no voltage or current flowing anywhere in the factory right now. Everything has completely stopped. It is all powered off, even the heavy motors. The motors are off, this one isn't spinning, my elevator stopped. So, for example, I can simulate a transformer switching operation. There are two transformers, they're in parallel, I can take one out, I can take the other out, bring one back. So here's what I'm going to do. I'm simply going to open one transformer, open my cabinet and energize my... I closed it, it turns green here, and the other transformer, it also, it was open. So with both switches it can't work. So I'm going to open my circuit breaker, go back and close this switch here. They weren't in parallel, the two transformers. I'll come here, close my circuit breaker, energized it, listen to the sound of the transformer, and it's energized. And why did it energize, folks? The bottom part of this transformer here is the return, it's the voltage return that comes from the panel. It doesn't mean it's connected to the grid, it's just the voltage return. So the voltage passes through this transformer, goes to the panel, and comes back through here. But that doesn't mean it's operating. Well, folks, this is the primary substation. Here we have the CTs and PTs. In short, everything needed to give a lesson on primary substations and contingency simulations like what I did here. I can create simulations saying, look, I lost the capacitor banks, the circuit breaker protection tripped, or this transformer. There was a fire here and I have to switch the power source. In short, the simulations will be according to the client's needs. Well, folks, that's what I had to present, and I hope you understood how it works. And this is what we are offering to do for the DOR network.